Okay, today I'm going to talk about moment of a force, and this is a little bit of a discussion about mechanical advantage, but we talk about moment of a force in a lot of different ways, and the reason it gives us an understanding of mechanical advantage is mechanical advantage uses moments of a force to its advantage. So everyday tools, we have a hammer. This one's blue and this one's red. Now what I've done is I've placed a nail in this board, and in setting it up to pull the nail out, this red hammer has a pivot point where it contacts the board, marked here with an R. I've marked it as a point here. So this nail distance to the line R is further away than the distance I have marked for the blue hammer. So they have slightly different distance in its initial leverage of the force, but there's another difference in that if I lay them down on top of each other, you see the red hammer is shorter. So it has a less of a leverage from its pivot point up to where you might pull from. It might be 12 inches for the red hammer, whereas it's closer to 13 for the blue hammer. So the mechanical advantage, if anyone who has used hammers can attest, if you have a bigger hammer, it's going to be a little heavier, but it also gives you the leverage you need to pull the nail out a lot easier because you have a greater degree of control. You have a force pulling out with your hand. You pull towards the right in this orientation. You pull with that force, and you're going to pull that much, and down this handle is going to transmit that force through a moment. So that force is going to transmit across a distance of 13 inches down to the pivot point, which is this closer blue line that I have marked. And then it's going to try and pull the nail out. Well, then in order to pull the nail out, it's got to retranslate that bending back into an up-down force, which is a force couple, that then it takes advantage of the short distance it has between the nail and the pivot point to amplify the force actually being applied to the nail. So I'll go over what that looks like in math, but when you have a wimpy ISU hammer, for example, versus a stronger, a wimpy IU hammer versus a stronger ISU hammer, you're going to have less advantage because when I use this one, the IU hammer has only 12 inches of leverage to transmit the same force. I'm assuming that the same person is only going to be able to pull the same amount of force on this hammer, but they only have 12 inches of leverage. They're going to pivot this leverage over a longer distance to pull the same nail out, and it's not going to translate to as much of a pull out force on the nail. So I'm going to show you what that means in mechanical leverage, but first we have to figure out some of these distances. So the distance between the nail and the blue hammer pivot point is 1 1/4 inches. So we will mark that 1 1/4 inches. And the distance between the nail and the red hammer pivot point is 2 1/2 inches. That is here to there and here to there on our measurements. Hopefully you can see that. And our leverage for a force on the red hammer is 12 inches, and the leverage for the force on the blue hammer is 13 inches. So I'm going to translate that into math for you in the next video segment.